All right, welcome. Today we're going to have a little video lecture here on section 1.1 on the structure of data. And as you'll see, we really have three things that we're going to want to talk about: cases and variables, types of variables, and explanatory and response variables. We'll take each of these in order. So let's look at cases and variables first. And we have to imagine the following scenario just to help us get started here. You have volunteered to help collect information for the Truckee Marathon and Half Marathon races. Now, Truckee is a community that's near Lake Tahoe on the border of California and Nevada, and they have a marathon and a half marathon race every year. Now, you volunteered to help work with collecting information. So the questions that you have to consider before you get started is: what type of information will you collect? What will you do with this information? And how will you present this information? So these are all critical things that you're going to want to ask yourself before you would get started in this project. So let's take a look at the situation here. So we have to imagine that every runner in the race has a halo of information surrounding them. There's a tremendous amount of information that could be collected about every single person that's in this race. Now, in the language of this section, we're going to think of a runner as a case. So in other words, a case is a subject, right? And a runner is going to be a case, and we have to think of all of the information that's associated with this runner as a possible variable. Now, the question that we have is, since we're running a race, we know that some of the information about the runner is going to be very important, and some of the information about the runner is not going to be important. And as we think about this ahead of time, we'll probably come to the conclusion that the following variables are going to be most important, right? So we're going to want to know the name of the runner. We're probably going to want to know the gender of the runner, the age of the runner, the hometown, the event that they're running in. Are they running the marathon or the half marathon? And probably significantly important will be, what was their finish time? So we think about the case for this data set, and each case is going to be each runner, and associated with each runner are going to be a set of variables, in this case, these 6 variables. Okay, now, how are we going to imagine collecting and presenting this information? So here's one simple way, right? We could imagine that at the end of the race, each runner has an index card associated with them, right? So, for instance, we've got Jill Vahidi. She's a female. She's aged 50. She's from Grass Valley, California. She ran the half marathon, and she finished with a rather respectable 1 hour, 54 minutes, and 53 seconds. And so what we can think of is each case is associated with a single index card that contains all of the variables that are important to us, right? And what we could imagine doing is collecting all of our index cards at the end of the race. We'd have all these index cards. We could collect them together and stuff them into a box like this. And we can imagine that this is a way to organize our data. Okay, now, what's good about this is it gives us a way to visualize the data, and we can imagine all of the cases. Each case has a card, and all of the cards are together in this plastic box, and this is our race data. And there's something good about thinking about the data organized in this way. Now, it has some problems, but it has some strengths as well, because it forces us to think of a case as a card in this box, and every card has some information, these 6 pieces of information on them. So I always want us to be able to think of, in some sense, the data being stored in this way. It's not the most useful way to use the data, as we'll see. Now, let's look at another way to think about storing this data, and this is a much more natural way, given that we've spent a lot of our lives thinking about Excel spreadsheets. So let's take a look at another way to store the data. In this way of storing the data in a spreadsheet, we can imagine that every single case is a row in this spreadsheet. Every row in this spreadsheet represents a case, a different runner in the race. We've got our friend Jill Vahidi down here in row 17. There she is. So here's another way of storing the data for this race in rows and columns. We can see the columns are labeled place, name, city, bib number, age, gender, event, time, and pace. So we've got a few more variables in here that we didn't include on the index card, but those are helpful for the race management situation. So let's take a look at some questions that we might have, right? So looking at the spreadsheet, what do the rows represent? Well, let's think about that. Each row is essentially the same thing as an index card. It's a case or a subject, or in this case, a runner in the race. What do the columns represent? Well, each column represents a different variable that's associated with that runner or that case. All right. Now, most importantly, though, now that we have the information stored in this way, what questions could we investigate with this data? So, as opposed to thinking of our data simply stored in a box like this, which is fine, to storing our information this way present us with some ways of seeing questions that are in the data? And I think the answer is yes. When you see the data presented in this way in rows and columns, it does begin to suggest the kinds of questions that you think, well, now that I see the data presented this way, I can kind of ask some questions. Some questions seem very natural, right? So just looking at this gender column, we could ask ourselves, well, what proportion of the runners in the race are male and what proportion of the runners in the race are female? Looking at the event column, we can ask ourselves, what proportion of the runners ran the half marathon? What proportion of the runners ran the full marathon? Looking at the time column, we could ask ourselves, what was the average finishing time for the half marathon? Or what was the average finishing time for the full marathon? Looking at the pace column, for instance, we could ask ourselves, what was the average pace for the race? Or more interestingly, perhaps we could ask ourselves, was the average pace for the half marathon faster than the average pace for the full marathon? We might be surprised. We might think that the answer to that question should be obviously yes, you should be running at a faster pace for the half marathon. But we might be surprised when we actually look at the results to see that the marathon runners, who are probably the fitter people in the race, might be having a faster per mile pace. But that's something we can explore now that we see the data laid out in this way. So we've got a couple of different ways to think about an experiment, cases or subjects, variables that we want to keep track of regarding every case. We can think of them as stored as index cards in a box, which is helpful. But we can also think of them as stored in rows and columns in a spreadsheet. And we're going to stick to this basic idea that a row will represent a case and the columns will represent different variables associated with each case. Of course, we could transpose this and reverse the rows of rows and columns, but this is the way we're going to want to think about organizing our data, especially if we're going to use some statistical software. All statistical software that I know of seems to operate on this paradigm where the rows represent cases and the columns represent the variables. So as we leave this section, right, the goal of this section was to kind of articulate the idea of a case and a variable. And as we leave this section, let's just recapitulate what we've got here, right? So we obtain information about cases or subjects in a data set and generally record the information for each case in a row of data, in a row of a data table. A variable is any characteristic that is recorded for each case. The variables generally correspond to the columns in a data table. All right, so we've got the idea of cases and variables hopefully firmly in our mind. Rows give us cases, columns give us variables. Now, what we want to do, and we've already seen this when we looked at the Truckee Marathon data, there are different types of variables, and the kind of questions and the way we treat these variables are going to be different depending upon the type of variable that we have in question. So let's move on to types of variables. Now, the textbook really only worries about two of these types. There is a third type that I want to mention only because it could become a source of confusion for you, not so much in this course, but at a later point. So we're going to look at what are called categorical, quantitative, and ordinal variables. Now, the confusion is that an ordinal variable is in fact a special type of categorical variable. So really we have categorical variables and quantitative variables, and then within the category of categorical variables we have what are called ordinal variables. All right, let's take a look at a categorical variable first. Broadly speaking, a categorical variable divides the cases into groups, placing each case into exactly one of two or more categories. So you have two or more categories, and a categorical variable just assigns a case or a subject to a group, one of those groups. So for example, thinking about the Truckee Marathon data, an example of a categorical variable is, what is your gender? I'm going to put you into the female category or the male category. I'll put you into the half marathon category or the marathon category. All right. Even your hometown is a category, right? We saw that Jill Vahidi was from Grass Valley, California. That is a category, right? Now, there are a lot of hometowns, so the number of categories could be enormous, but the hometown is a way of placing Jill into a category. She may be the only one from Grass Valley that entered the race, so she may occupy that category all by herself, but so be it. That's an example of a categorical variable. Now, next up is a quantitative variable. A quantitative variable measures or records a numerical quantity for each case. Numerical operations like adding and averaging make sense for quantitative variables. And what we really should think of as a quantitative, and when we're thinking of creating a data set, we should always have in mind for a quantitative variable, what are the units that we will be using to measure and record that quantitative variable. So when you think of a quantitative variable, you should think automatically of the units that are associated with that variable. Categorical variables don't have units, but quantitative variables have units, and that should help you think about when you're populating your spreadsheet, what are the specific units that I will be using to record this quantity in. Okay, so that's a helpful thing to think about, is always think about the units that are associated with that measurement. Last but not least is a special kind of variable called an ordinal variable, which is kind of masquerading as a quantitative variable, but in fact is a categorical variable. So an ordinal variable is a categorical statistical data type where the variables have natural ordered categories, but the distances between the categories are not meaningful. Okay, so that's an example of an ordinal variable. We'll look at a special case of that, and hopefully that'll become clear later. But when you have ordinal variables, you do have numerical categories, and they do have some sense in terms of their order, but they don't have any absolute sense. In particular, there are no units associated with ordinal variables. So that's hopefully when you encounter an ordinal variable versus a quantitative variable, you'll be able to sort out what type of entity you're looking at. Okay, let's take a look at an example of a pure categorical variable that is not ordinal. Okay, so when we go back to our Truckee Marathon data, and I used StatKey to help create this graphic, I was able to, up here you can see the file that's being accessed here. It's the Truckee Marathon's 2017 file, and I asked it to look at the column labeled gender, and it splits the all of the cases, all of the subjects into the male and the female. So you can see we've got two categories. We've got male and female, and it takes all of the runners and immediately populates them into these two categories. And so all of the cases, all of the runners are here amongst these two categories, male and female. And one nice thing about the visualization that we have here is we can immediately see, without getting into the exact numbers, we can immediately see through this visualization that there are more female runners that day than male runners that day. Off to the side here, we can get the exact counts and proportions. So we have a total of 198 runners, 83 male and 115 female, and there are the corresponding proportions. All right, so this is an example of a pure category and not a quantity. All right, now, if we want to look at an example of an ordinal variable, we don't have to think too hard because we see these things all the time. We probably haven't put a name to it, but we've certainly seen this kind of ordinal data all the time. All right, so anytime you're buying something at, for instance, Amazon, you're probably paying a little bit of attention to the customer reviews and the customer ratings. And basically what Amazon wants you to do is to take the product under review and give it 1 star, 2 star, 3 star, 4 stars, or 5 stars. And you can keep track over time of how the consumers have rated this product. It's a helpful way of understanding what am I getting myself into if I'm buying this product. If it has, mostly 2-star ratings, I'm concerned about that. If it has a lot of 5-star ratings like this product, I'm feeling pretty good about my purchase. Now, the numerical values 1, 2, 3, 4, and 5 have some meaning, right? We know that 5-star means more than 4-star, means more than 3-star, means more than 2-star, means more than 1 star. But the thing about this is that there are no units associated with this, and there is no way to say that the difference between 1 star and 2 star is the same as the difference between 2 star and 3 star. So in other words, the differences between these values really don't have any meaning. We just know that 5 star is better than 4 star. Now, one good way to think about ordinal data is you have to ask yourself, it's the interpretation, right? If I saw this same chart here and I permuted or changed the order in which these star ratings appeared, it would be confusing to you because you naturally think of 5 stars as the best and 1 star as the worst, and you'd like to see this categorical data laid out from 1 star to 5 star because that has meaning. That's a kind of an important aspect of this ordinal data. On the other hand, if we go back here and I take these 2 columns, the male and the female, and I permute them, there's really no confusion there because we don't expect those categories to have a natural left, right, or up, down meaning to them. So ordinal data is categorical data, but the values, in this case, the 1 star through the 5 star, do have the effect of putting ordering or meaning into the categories. Okay, so ordinal data is kind of mixed. It's got values, it's got values that have meaning, but it doesn't have units, and the differences between these values is in the end not meaningful. Now, one of the things about ordinal data is you have to ask yourself, are some of the mathematical operations that I typically do on quantities, is that justified or meaningful for ordinal data? So you'll notice up here that Amazon will always report the average score of ordinal data, and you'd have to ask yourself whether or not averaging ordinal data actually makes sense in the same way that averaging quantitative data makes sense. So that's one aspect of working with ordinal data. And you'll see people treat that question very, very differently. So some people will say, yes, you can average ordinal data, and other people will say that that's, strictly speaking, not that sensible. Okay, let's take a look at a problem where you might see data collection and different types of information that's going to be collected. And let's just make sure that we can kind of quickly assess what kind of variable we're looking at, right? Are we looking at categorical or quantitative? And if it's categorical, are we looking at a kind of pure categories, or are we looking at ordinal categories? So let's take a look. You walk into a doctor's office, you have a severe headache, and the office staff is going to collect some information before you go in to see the doctor, right? Typically, they'll want to know things like, what is your insurance company? What is your weight? What is your height? What is your current temperature? And maybe since you're coming in with a headache, they want to know, what kind of pain level are you experiencing at this point? Okay, so let's take a look at each of these and ask ourselves, let's look at the following questions, right? So in this context, right, what is the case? All right, so what is the subject? And if we think about this, the subject is you, the patient. You're walking into the doctor's office. You are the case. And this halo of information are all the variables that are associated with your case. Okay? Now, for each of these 5 variables, let's determine whether it's quantitative, categorical, or ordinal. Now, I want you to think along with me, so if you want to pause the video as we look at each of these and try to make your own guess, please guess along with me, work along with me here. So let's take a look at the insurance company. Would you count that as categorical, pure categorical, let's say quantitative or ordinal? All right, so if you want to pause the video here, that would be fine, but I'm going to say that that is a pure category. Your insurance company is a pure category. Now, there are a large number of insurance companies that will provide health insurance, so maybe the possible answers here are quite large. So maybe it's Blue Cross, maybe it's Cigna, etc. So it is a large number of categories possibly, but that is kind of breaking you into one of those several categories. So we're going to count that as a categorical and variable. What about your weight? Category or quantity or ordinal? I'm going to count that as a quantitative variable. One of the dead giveaways, of course, is I can think of units that are associated with that measurement. So I'm thinking that typically in America, we would measure your weight in pounds, in Europe in kilograms. Okay, height. What is your height? Again, I'm going to count that as a quantity. That is a quantitative variable, and the units, at least in the US, that we would associate with height would be feet and inches, or maybe just inches. And let's move on to the next one here. Temperature, are we going to count that as a quantity or a category? If you're thinking along with me, hopefully you've come to the conclusion that it is a quantity. And again, we would measure that typically here in the United States in Fahrenheit, and other parts of the world in Celsius or centigrade. And finally, your pain level. If we think about this, if you've ever experienced this kind of question, they might give you a scale from 1 to 5 or from 1 to 10, where 1 usually represents very, very mild pain, and 5 or 10, depending upon what the upper level is, will be in incredible excruciating pain. And they're going to ask you to kind of fill in a little dot or check a box that indicates your current pain level. And if you think about that, that's a categorical variable, but it is asking us to think about the categories as ordered, so that will come under the heading of an ordinal variable. All right, so that's very typical to have some ordinal variables like that as a way to measure pain. Okay, if categorical, what are the categories? We talked about that. And if quantitative, what are the units? And we've talked about that. So this is something we should always be attentive to when we're thinking of categories. What are the categories? When we're thinking of quantities, what are the units that we want to measure in? Okay, so that covers the second section on types of variables, and hopefully you've got in your mind here that you've got categories and quantities. Those are the two big headings, and then within the categorical variables we have kind of pure categories, and then we have ordinal data. Okay, let's move on to our last and final section of or phase of section 1.1. We want to talk about explanatory and response variables. And this is kind of a way that we would naturally look at some variables in a data set. We would look at some of them as explanatory and some of them as responses. We think that the variables are in some sense interacting with each other, and there's a natural kind of explanation and response associated with them. So let's take a look at a typical example. This is something I pulled out of Forbes magazine, and it has to do with the connection between sleep and grades. So this quote says, "The closer students get to a full 8 hours a night of sleep, the better their grades, according to a new survey." So there's a new survey which has kind of a rather unsurprising result that says, getting more sleep at night is probably helping these kids get better grades. We probably tend to believe that because we think of an extreme where a child is not getting enough sleep, and we realize that their whole day will be worse. Not just their grades, but almost every aspect of their life is probably going to suffer from a lack of sleep. So this is not too surprising. Now, we might wonder whether or not 8 hours is the right number, or whether 9 hours is the right number, or 10 hours is the right number, depending upon the age of the child. But we're not surprised to see that there might be some connection between the amount of sleep a child gets and the grades that they're getting in school. Now, there are lots of other factors that are associated with a child's grades, and so we're not saying that sleep is the only determining factor, but we're sensing that there might be a connection between these two pieces of data. Now, what are we thinking? What is going on here? We're imagining that we've got all of these children, All right, and let's say we're going to study them for 1/4 of their school year, and we're going to ask their parents to cooperate here and kind of keep a record of how much sleep their children are getting at night, and then we're going to ask the school to provide us with some data on their grade point averages. But maybe at the end of the quarter, here are 4 different index cards of data that we've collected. We've got Leon, Sophia, Aubrey, and Diego having a certain number of hours of sleep that they've had on the average and their corresponding grade point averages, right? And what is it that we would be noticing as we look through these cards? We might be making a very casual observation. It says, look, as I look at this card, I'm noticing that as their average sleep is going up, it seems like correspondingly their grades are going up as well, right? So that as they get more sleep, it seems like they get better grades. And so we're starting to develop this kind of hypothesis that maybe the amount of sleep that they're getting, right, the more sleep they're getting, the more or the better their grades. All right, and so that's kind of a way that we're seeing into this problem, a kind of a connection between these two variables. One is helping to explain the other. All right, so let's take a look at a definition here, right? So if we're using one variable to help us understand or predict values of another variable, we call the former the explanatory variable and the latter the response variable. And you can tell by the way Forbes set up this question that they're thinking of sleep as the explanation, right? They're thinking of sleep as the explanatory variable and grades as the response, because they're saying, I think more sleep gives rise to better grades. That sleep is helping us explain grades, right? Now, we could try to twist this around, because we could also look at this same data and say it looks like as the grade point average goes up, their average sleep goes up as well. But there's something in nature that tells us that that is not really a kind of a correct relationship between an explanation and a response. Now, there's nothing wrong with the statement. It's certainly true that as their grades go up, so does their sleep. But we kind of have some intuition about this that says bringing a child's grades up doesn't make them sleep more at night. That we understand that that probably is not a proper kind of correlation between an explanation, an explanatory variable, and a response variable. So we have to kind of bring some common sense into this and kind of think of the situation, all right? But we have in this experiment the idea that the sleep and the grade point average are connected as an explanation and a response. All right, let's take a look at a problem. In each case, identify the explanatory variable and the response variable and identify the type of each variable. All right, let's take a look at this first question. Can I predict your party affiliation from your religious affiliation? All right, which of these is the explanatory variable and which is the response variable? Well, the question gives it away pretty quickly. Can I predict your party affiliation? So if we're trying to predict your party affiliation, that is clearly the response variable. And your religious affiliation is the explanatory variable. So for example, knowing that you're Catholic, can I make a pretty good prediction about how you'll vote, which party you'll vote with in the next election? That's what this question is getting at. Now we'll notice in this case, in this example, that each of the variables is a category. So we're trying to use membership in one category to explain membership in a second category. So 2 categorical variables in this case. Next question. Do domestic cars depreciate faster than foreign cars? So what am I trying to predict or explain in this or what is this question implying about what I'm trying to predict and what I'm trying to explain? And it's pretty clear here. I'm trying to explain depreciation, the rate with which your car is going to lose value. And what am I using to help me form this explanation? I want to know whether or not you have a foreign car or a domestic car. I'm trying to understand how knowing which of those 2 categories you're in is helping me explain how your car is depreciating. So our explanatory variable in this case is which category of car do you have, and our response variable is the rate with which your car is going to lose value. All right, so we have a categorical explanatory variable and a quantitative response variable. All right, should I give you a Tylenol for your fever? Should I give you a Tylenol for your fever? So we all understand that we think that normal human temperature is about 98.6 degrees Fahrenheit. If you're slightly elevated from 98.6, I may not give you a Tylenol for your fever because there might be another reason why your body temperature is slightly elevated. But at 102.3, for example, we're probably going to give you a Tylenol because we would see that, at least in an adult, 102.3 might be a dangerous temperature to maintain for too long. So we're going to want to bring that temperature down. We're going to give you a Tylenol. So what do we have here? We have this quantitative explanatory variable, your body temperature, triggering a response which is in a category, right? Do I not give you the Tylenol or do I give you the Tylenol? So we can have a quantitative explanatory variable which is helping me understand my response, which is give the Tylenol or do not give the Tylenol. So we have a quantitative input and a categorical output. Final question. How does your heart rate affect your systolic blood pressure? So in this case, we're thinking of trying to explain the systolic blood pressure by knowing your heart rate. All right, so we're thinking of the heart rate as the explanation or the explanatory variable, and the systolic blood pressure as the response variable. It's responding to, we're hoping to understand how it's responding to your current heart rate. Now, what's interesting in this last example is that each of those variable types is a quantity. So we have one quantity explaining another quantity. Now, I've chosen these examples with some care because we have two main types of variables, right? Categorical and quantitative. And we have two types of response variables, therefore categorical and quantitative. And so we can see that there are four different possible interactions between these variable types. And I've put them into this table here. So you can see, how is this 2x2 table formed? I've got my explanatory variable are forming these two rows, categorical or quantitative, and my response variable is denoted by these columns. So they can have categorical response and quantitative response, and that gives rise to four different interactions. And each of our four previous examples fits into one of these possible interaction types. So for example, I can have a categorical explanatory variable and a categorical response. Does knowing your religious affiliation tell me what party you're likely to vote with in the next election? Or I can, for instance, have a quantitative explanatory variable and a categorical response. Does knowing your temperature trigger a response to give you a Tylenol or not give you a Tylenol? So all of our four examples fits into one of these four categories. Now, why is this important? It's really important to recognize the types of variables that you're studying when you're looking at these explanatory and response type questions, because each of these four categories has a very, very different kind of analysis associated with it. So knowing which of these four categories you're in is going to present you with different statistical tools and different types of statistical analysis. So you really, really need to classify your problem and understand where your problem fits into this general scheme. All right, so that's an important thing to know. All right, so that brings a close to section 1.1. Let's just kind of review very quickly what we've been trying to do in this section. The first thing we talked about were cases and variables, and that was just trying to understand that in a typical statistical study, you have cases or subjects, and associated with those cases or subjects, you have this halo of information that you're trying to keep track of. And one way to think of that is simply on an index card. Every case or every subject has an index card full of information, and we can think of storing those cards in the deck, or typically more helpfully in some spreadsheet where the cases form the rows and the different variables form the columns. We also then went on to recognize that variables come in different types, and the two main types are categories and quantities, okay? And then within categories, we have pure categorical variables or ordinal variables, all right? And so we would want to know, are we studying categories or are we studying quantities? Very, very different types of analysis will be done on those two different variable types. And then finally, we saw within the world of variables that many, many interesting statistical questions are trying to relate variables to each other as explanation and response. All right. So we want to not just look at our variables as just things that kind of exist in their own, but variables that are actually interacting with each other. Okay. So we want to look at variables as being possibly an explanatory variable and an associated response variable. That's very, very typical. So that ends section 6.1, and I will meet you again for the next video lecture on section 1.2. Until then, take care. Bye-bye.